So I'm going to start with a couple questions. What powers machine learning? We kind of think about this a little bit, right? What's the oil that machine learning runs on? Right? It's knowledge, right? Machine learning is powered by knowledge. It's history, right? Machine learning runs on history. It's a backward-looking thing. And of course, that crass word for knowledge or for history is data. Machine learning runs on data, right? The more data, the better the data, the more the innovation. Great data usually beats great algorithms. Now, great innovation comes from machine learning that mines great data. But one of the questions that I want to ask today is, who's going to bring about these innovations? Will these innovations be broad-based or be kind of concentrated by some sort of select few? That's a very important question. I want to get back to that question at the end of the presentation. But before we dive into that quote-unquote philosophy, I want to talk about a little bit the data ecosystem and ultimately some of these advantages that some of these companies have. Anyone who's done anything in machine learning has seen this slide. This is a very famous slide from Microsoft Research. And basically, the slide shows that the better the data set, the bigger the data set, will change which algorithms win. In this case, the worst algorithm with a small amount of data becomes the best algorithm with the largest amount of data. The best algorithm with the smallest amount of data becomes the worst algorithm with a lot of data. And this was a speech recognition thing that Microsoft Research did, but it often can be true. So it's very hard to know which algorithms win. But all the algorithms do better as the data gets better. Every single thing gets better as the data gets better. Now, organizing past data at scale is super hard. Anyone who's ever done anything on that knows it's just a super hard problem. You have to acquire the data, you have to host the data, we have to prepare the data, we have to understand the data privacy. So I'm going to talk to you as like an example, as a startup. We'll talk about a fictional startup here and walk through like why this is so hard. Okay, so you're an innovator. Let's say your goal is to match better oncology. I heard someone talk about oncology. So your goal is to talk better oncology treatments with patients. And you're sure that, of course, machine learning can save lives, and it can also massively reduce suffering in this area. And you've got a core passion. Maybe you're a cancer survivor yourself, or you have a relative that went through a hardship, and so you really want to solve this problem. But first, you've got to get access to this data. How do you get access to this type of data? Getting access to the true sets is really step one in really getting some sort of learning. Okay, fast forward 2 years later, you finally got access to data. You built a BD deal with Aetna. You got oncology data from 800 hospitals. Now you need to stand that data up in some sort of big data infrastructure, which can, as anyone here knows, can be like a super big nightmare. Okay, so you've hired all these great, people. You stood up the data. You've got some sort of like Spark infrastructure streaming the data in with Kafka. But guess what? The data is super dirty, of course, right? You have data that's coming in from 800 hospitals, and it turns out it's coming in 620 different formats. All of you probably experienced this thing, and that's because many of these hospitals store their data in 20 different systems, and you have to pull the data from all these different systems and bring it together and deal with it. So now you have these great machine learning engineers, and they thought they were going to be spending all their time predicting the future, but it turns out they're spending 95 to 99% of their time organizing the past. My friend Mike Driscoll calls this data munging. And any of you who have done machine learning, you know this problem. You've spent most of your time on this problem. Okay, you finally got the data in one place, and you're just an ETL machine. Everything's working great. Okay, but hold on. What are the privacy implications of this? You've got a lot of people's sensitive medical records. You need to build some sort of team to help you understand how to protect the data. And of course, keeping that data secure is a huge issue. You're going to build a security team, run penetration tests. Or of course, you're going to be out of business if you have some sort of breach. Okay, wow, this is a crazy amount of work that we just went through. We just did a whole bunch of things. This is a crazy amount of work. Now if you just take this machine learning engineer that had to do all of this and take that same machine learning engineer and she joins Google, what happens? Well, she doesn't have to do any of that stuff, right? Google, the data's already there, it's already stood up, the data's in good shape, they have a whole privacy team and security team to deal with all this stuff. As a machine learning engineer, now you can spend 95% of your time predicting the future, which is what you want to do as a machine learning engineer. So this is the core struggle for almost every single company, except for maybe Google, Facebook, Amazon, Tencent, that has to deal with all these types of issues. So that leaves us to the question that I asked at the beginning of the presentation, which is who's going to bring about these innovations that are happening in machine learning? Right, I think there's two potential futures that are out there. One future is a world where kind of all the important data, consumer behavior, health outcomes, economic and the like, resides with just a very small number of giant companies. And these companies will, of course, jealously guard that data because it's a competitive edge. And many of the speakers tonight talked about that. And because they have a monopoly on the data, they could monopolize innovation. Yes, some innovation will still happen, and some startups and some other companies, some research labs outside of those big companies, but the bulk of the world's innovation could be concentrated in the hands of very few companies that actually contain knowledge, they contain history. And monetary gains from that innovation will go to an increasingly narrow group of people. Now, that's not necessarily a bad world, and that's not an evil world, but that might not be a world that many of you want to live in. Now, of course, there's a second version of the future. The second version of the future is a world where access to data, access to knowledge, access to history is made available to many or all potential innovators that are out there. In this kind of version 2.0 of the world, data is democratized and innovators everywhere can build on knowledge. One kind of anecdote, one recent catalyst in machine learning has been kind of the invention of TensorFlow. How many people here have played with TensorFlow? Okay, a lot. And it's a great machine learning model. It makes it especially easy to develop these machine learning models. In my opinion, it's one of the top 10 innovations in the last 10 years. It's already created very, very large gains in deep learning, and I think it's amazing. Now, Google put its top engineers on TensorFlow. The number one, probably most famous engineer at Google, certainly the highest compensated engineer at Google, Jeff Dean, was the guy who led the team to build TensorFlow. They may have spent over $1 billion developing TensorFlow. And then Google did, I think, the unimaginable. They open sourced it. And so now, not long after Google open sourced the project, I was meeting with a buddy of mine who was one of the core engineers on the project. And I asked him, why would Google open source this amazing innovation? Right? Isn't machine learning core to Google's future? Why wouldn't they want to keep it for themselves? And he calmly looked at me and he said, hey, Auren, it doesn't matter. We have all the data. So back to our two futures. In the first future, there's a small number of companies that have all the world's data. In that world, even the most advanced models, deep learning, and machine learning frameworks can't beat them because they have access to this kind of core underlying data. Here, basically, brute force beats any type of beauty. Brute force is the one that wins. In this future, a small number of companies could command the most innovation rents. But in the second future, the one where all the innovators can get access to high quality data that they need, innovation is prized over brute force. Because all innovators have access to kind of this truth data about the world, the gate isn't the past, but the future. Here we value creativity, here we value innovation, here we actually focus on the future rather than on the past. Now, the second future is not such a far-off world. It's not this crazy world. We already have democratized access to compute power, right? Today, it's available to anyone. And no, it's not free, but anybody here, and probably most people here, have used democratized access to compute power. And the price, because of things like containers, et cetera, the price of accessing compute power has gone down every single month. So we can have access, open access to information to basically power innovation. Information does not need to be hoarded so that only a few people can innovate. My belief is that as many organizations as possible should be working on the biggest challenges of our future. If you think of this oncology thing, it'd be great if every organization was focused on this and not just a few. Data shouldn't be an open platform. It shouldn't be necessarily a trade. It should be an open platform, not necessarily some sort of trade secret that's out there. If the best innovators get the access to the most data, we're going to see the most innovation. That's it. Thanks.
Thank you very much. And thank you for not using the opportunity to pitch. However, now is your time, your chance to do so. I'm guessing that the company may be an answer to this question.
I think there's, if you think of the last 10 years, the best companies in the world of data, machine learning, or just in general, the best companies that have helped, we've been a much more data-oriented world in the last 10 years. And almost every company that's taken advantage of that has helped the companies themselves use their own data better. So these are companies like Palantir, they're the BI tools, even things like Hadoop or Spark. Basically most of these companies are basically, let me take your own data and help you make better decisions with that data. But most companies out there, their own data represents like 0.01% of the world. Unless you're Google, Facebook, Amazon, Tencent, a couple of others, you have a very small sliver of what's happening in the world. And so helping you with your own data is really valuable, and those companies will continue to do really well in the next 10 years. But there will be a class of other companies, maybe SafeGraph being one of them, but the class of other companies, there'll be iconic companies that help you understand the broader world, not just your own little microcosm what's happening.
Great. So to the extent you can talk about it, do you want to describe some of what SafeGraph does? And
Sure.
You started with location data.
Sure, yeah. So SafeGraph's pretty simple. So it's really just about one core truth set, which is how people interact with the physical world. So where do people go in the physical world? And so companies like Google have great access to this data because they have 70% of the phones in the US that they have data on, and probably even a higher percentage of phones worldwide that they get to see all this great location data on. But there's a lot of other people that want to be able to innovate on top of that data.
Okay, and I think you guys built this very interesting consortium around open sourcing some uneducated location data. Is that correct?
Yeah, as one of the other speakers kind of alluded to before, the best data companies, and data companies are actually pretty rare. There are very few data companies out there. Most companies that are quote-unquote data companies are actually application companies. They take some sort of proprietary data. And I think one of the other VC speakers kind of talked about the types of companies he wants to invest in. They're basically taking some sort of proprietary data set, keeping it proprietary, and then building some sort of application around it. There are many great data companies that do the opposite, where they basically just say, here's the data, now you build the applications on top of it. And so if you think of a great data set would be ones that really kind of fostered innovation in a particular space. So if you think, many of you are probably in the financial industry, so many of you have seen a very simple data set, which is price per ticker per time. And that's just really high quality data. That goes back over 100 years. You want to backtest AT&T, you can go back over 100 years. Now maybe 100 years ago, the tick was a day, and now it's a tenth of a second or something, but it's very important data. The other thing about data is that it's more valuable if it's temporal. So that's great data because it's temporal. It has stuff in the past, but you constantly need the new data stuff to keep your models fresh and going.
The idea that you start with location data and then you move on to other data sets and ultimately build the data for everything?
we'll never get to complete history. So our goal is to figure out what happened in the past. We want to organize the past and then let our clients organize the future. So our goal is to figure out what happened, where it happened, and when it happened. So we see ourselves kind of like an archivist where we're archiving history and then giving people access to history. Now, we're never going to have complete information or complete history. But one of the things, if you really want to know, like, where is innovation going to happen in the future, I think you can really look at innovation as to where we have data today. So probably oncology is a place where we'll probably will see some innovation because there's a defined data set. There are definitely some vendors today that have access to really good oncology data. So I expect that we'll see a lot of really great innovation around different treatments for people, personalized stuff for people, et cetera. And I think we'll see a huge innovation in the next 20 years. On the flip side, if you think about nutrition, likely 20 years from now, we'll still have fad diets. It's just incredibly difficult to collect all the data of everything that goes into your body, your eventual outcome, which could be like 50 years later, your income. You probably need to throw your DNA in there, and so it's just an incredibly difficult data collection problem. So I don't expect that we'll have a lot of progress in nutrition in the next 20 years.
Maybe just one last question from me. You mentioned data privacy, which is a fascinating topic. How does that work? So you're creating an sort of index of the data you get and the privacy rights attached to it, because privacy laws, if you're building a whole history, privacy laws may be completely different. Like GDPR did not exist a few years ago, and it does. How do you implement that?
Yeah, and it's different jurisdictions, right? So and it could be weird overlapping things or different types of things. It's really, really difficult. It's really hard. Ultimately, probably what you want is some sort of like privacy as a service as well. So instead of getting the data yourself as an innovator, you might want to keep the data where you can't see it, and maybe you can like put your algorithm in a container, run against the data, so you don't have to worry about some sort of these privacy issues. So you'll, for instance, anyone who's ever been like maybe doing machine learning, there's probably certain data sets that you salivate over that you wish you could access because you could really learn a lot. One would be like a lot of these hospital or Medicaid or other types of data sets you could just build just incredible innovation, but these have this many huge privacy issues around it. Another one would be the IRS data set. So you could do a longitudinal study of the kids of people who were low income. How did those kids do? What happened? Those kids that were in charter schools, that were in low income, that did that. You could start to run like all these like really, really interesting things. But obviously the IRS has like very strict privacy. So somehow the more interesting data, the more privacy issues around the data, especially when you're dealing with people. So ultimately, I think as an innovator, you might not even want access to the core data, but you might want to run your algorithms or run your things against the data in some sort of privacy-friendly way. That is not built today, at least that maybe someone here will tell me differently. But I expect within the next 5 years, we'll probably have answers to some of those problems.
Thank you very much. Fascinating. Do we have questions?
Another coming right after this, the data acquirers residing in the healthcare space. They are part of forests and food and analytics. They understand about the data. I was just kind of curious with your company, why is somebody like your Stanford involved? The former House Majority Leader.
Oh, like our investors?
Yeah.
So yeah, we have a weird company. We have 120 investors in our company, and I think when you're building a horizontal solution to build data for many different verticals, there are a lot of verticals that we don't know a lot about, and that we want to be able to build data sets for. So we come from the marketing and advertising world, so we know a lot about marketing and advertising, but we don't know a lot about self-driving cars. We don't know a lot about healthcare. We don't know a lot about government use cases. We don't know a lot about traffic. We don't know a lot about like working with, for instance, like if we wanted to work with the CDC, or all these other types of things if we want to help people, academia, historians, et cetera. So we try to get a broad base of investors to help us.
Hi, thank you. Just to go really high level here, you said innovation is going to go places where the data is. You think about a country with everything you said about privacy, you think about a country like China, who really have the talent, but don't have as stringent rules on privacy and data. Do you think that's going to change the landscape of where this sort of machine learning, artificial intelligence innovation is going to happen in the world?
That's a pretty interesting question, actually. Probably. So I think there's obviously a ton of advantages that China has in general. And so, like in genomics, I think BGI is super interesting. And so if you just go down the list, there's certainly a lot of regulations that China has that the US doesn't have, and vice versa. And so we could see, it's very possible we could see more machine learning innovations, or at least in certain areas, like maybe in healthcare, for instance. We might see more machine learning innovations that happen in China than happen in other places. So it's possible they'll have certain advantages. And there's always this kind of like interesting regulatory arbitrage that happens. So Mark Andreessen talks about this a lot, where if you are a regulator in a certain place and you want to build innovation, you can create some sort of regulatory arbitrage. So you can create, you can make your locality more drone friendly and get all the drone startups there, or you can get more bio-friendly or whatever it might be. Of course, there are drawbacks with this. Like some of the reasons that there's clamps on and there's regulators in the first place is that there's a lot of safety issues. So with bio, for instance, there's a lot of safety stuff that probably everyone here is concerned about. There's a lot of ethical things that many people here are concerned about. And so just because innovation happens, it doesn't mean it's necessarily good.
Right.
Right.
Thank you so much.
Yeah, thank you. Yeah.